Nice to meet you all. Thank you for joining us, Yuval.
100%.
It's a pleasure to talk to you. I had the fortune of visiting your data center locally here. That was very nice of you to invite us. So let's just start it. Maybe a quick introduction on your part, like why did you get into the data center space? I know you have like a long background in infrastructure, but why specifically?
Yeah, I started my career in data center about 17 years ago, and it was, for a very long time, I worked on core routers of the internet, a lot of optical business, and decided that I need to actually do a transition. Data centers was the most natural transition. I came into it from the networking side, but then expanded it to actually the work around servers and around infrastructure. I spent quite a bit of time at Microsoft doing this. I was working at LinkedIn as chief architect for data centers. I worked at Facebook as a principal architect for the hardware over there for networking, and spent a very long time at Cisco doing everything you can think of. The reason I started a startup doing a data center, which is complicated, is that I saw a window to be able to create a new type of data center, a data center that can run off-grid with a fully sustainable, with zero emission and zero water. That opportunity for a long time we've been told is not possible to implement. And I'm usually one of those people who say something is impossible, try to do it anyways. And fast forward to today, after the fast change that happened since 23 from ChatGPT, we got to the point that we're out of power. And being off-grid, being able to run in a sustainable data center is actually one of the best value propositions we can offer to the market today.
Thank you. So maybe I'll do a quick introduction about myself as well. I run a company called InfraCore, as well as another company called Riverguide Labs. Anyway, we build data centers. We're obviously working, hoping to work together soon. Anyway, so tell me about the most interesting part about, or the complex part, I should say, that maybe this audience will like to hear about, like as you went along solving the hydrogen, the EMS, as well as the actual construction of the high-performance computing data center.
I think when we started the journey at ECL, the first complexity that we had to deal with is actually we were dealing with the market of hydrogen, which did not really understand what is stationary power, how do you actually even consume it, what is the 24/7 delivery of hydrogen, and how reliability and purity is a key. It took us a really significant amount of time to work with the suppliers of hydrogen to be able to get to the point that they understand what's the value proposition and what's the offtake capability that we have. That was one part. The second part is we started doing liquid cooling in the data center pre-AI. And there were talks about liquid cooling before. We were using liquid cooling in 2020, 2021 to build a really high-end data center, which in retrospect was a great decision because today's AI machines actually with no liquid are just not surviving. We reached a point that we can deliver 150K racks, and I think you saw the racks yesterday in our data center. And 150K per rack is not just liquid. That's the challenge that a lot of people are just ignoring. It's 110 liquid, but 35K air. And if you look at the traditional data centers, they can do 8K air. That's all they can do. So even the air problem for most data centers is a challenge on top of the 110 plus kW. And if we're listening to what NVIDIA is messaging to us, we're looking at 250 and 600 in the next 3 years, which is a major challenge, and that requires new innovation. We can't do business as usual to continue to build this. So that was the second aspect. And the third aspect is scaling it very, very large scale. We're talking about gigawatts of data centers now. And scaling in a single facility is very complicated, and that's why we built it in a modular way, where we can actually scale a block at a time, and a block can be 1 meg, 2 meg, 10 meg, but it's a block at a time, and we can build in parallel a lot of blocks, and as a result, deliver platforms at hundreds of megawatts within months. And that's something which is also a game changer in our industry.
Yeah, I can't emphasize that enough. This is what excites me a lot, is literally in a matter of months, you can get 100 megawatts up and running. Talk to me about your your sources of like how can other people who are in the same space work with you in terms of you work being a client of yours or some other support that they can provide?
Yeah, so we are a co-location / private co-location provider. So working with us is relatively straightforward. If you have a demand to any capacity, if it's a 5 meg, 10 meg, or 300 meg, just reach out to us. Our cycle, like I said, for the first phase from PO to key is 9 months on a very high-end data center, one of the top 5% in capabilities of data centers. And then every incremental step that you want to do after that is a 6-month cycle. And we do this, we can do this, there's no magic in there. We do this because we are off-grid, so we don't have to deal with the utilities. And the second thing, our supply chain is a different supply chain than traditional data centers. We don't buy large components. Another model that we're willing to work with companies which are interested is actually a model of joint ventures. If you want to own the data center, we will build our technology into your data center or retrofit your data center, which is already existing, into a new data center. The data center that you visited yesterday used to be an empty warehouse with no cooling and no lighting. And now it's probably one of the top 2 or 3 data centers from an advancement of capabilities in the world.
Thank you. So you consume hydrogen, and we have talked about sources of bringing that to the table here. And then your innovation also lies in taking multiple unreliable sources of energy and making that reliable. Talk to us a little bit more about that.
Yeah, so I think one of the things that a lot of data center operators and customers realized, AI right now is creating a challenge on the infrastructure that we have not seen before. And the major challenge is fast transient on power consumption. We see transients of between 35 and 50% from baseline in a matter of milliseconds, and in the longevity of days at a time. So we can see up, down, 35 to 50 every 10 milliseconds for 3 days in a row. And it's probably a known secret that nobody talks about in the data center industry, but data centers that actually rely on diesel generators will fail. Diesel generators cannot track such a change. And to do what we did, we actually had to go and redesign completely the architecture. We eliminated the diesel generators, we eliminated the UPS systems, and created a multi-source energy feed into the data center. The sources can be DC or AC, so we can connect into a solar plant and take the DC directly from the panels. We can connect to any other source like geothermal or anything else which is available for us. Plus, we have on-site our own generation of hydrogen-based energy, which is zero emission, and the byproduct of it is water. So when you generate energy with hydrogen, the byproduct is water. So we actually take the water and bring it back into the data center for the liquid cooling. And with that, we're combining an active battery. So this is not a backup battery. This is a battery which sits there and always operates and takes care of fast transients which are happening in the data center. Without that, a lot of people look for other solutions. Batteries was one of them, looking for super caps and other solutions. And it's a challenge that's going to hit us more and more as soon as we get more and more high-end AI workloads into the data centers. And it's a problem that has to be solved. And the only way to solve it right now is actually to change architecture. It's not simple. It's not just, okay, let's add something X, Y, Z and it will work. It won't.
So think about, obviously you've done a lot of innovation here. I know you have a big patent portfolio there. When you think about call it the mainstream wanting to adopt you, what do they run into? Like, what are the pushbacks that you might receive, and then how do you counter against that?
I think the biggest concern that people have is what's the reliability if you're off-grid? How can you actually guarantee reliability? The one thing that we did, which is, we knew that's going to be the question. The one thing that we did from the first moment is we designed our site to be a tier 4 data center, which means 6 nines of availability. Every element in our data center is 2n+1. So a lot of data centers, which are traditional data centers, can achieve tier 3 or tier 4. But to do it in an off-grid is a much more complicated problem to solve because you don't have the baseline of the grid. So you have to actually innovate around how all the generation platforms that you have, how to actually make them highly reliable. You do it usually with under subscription of your system. You you undersubscribe the system by design, and then you double it up. And then you can actually get the 2n+1 redundancy into the system. That was the first challenge for people. The second challenge for people, they were freaking out from hydrogen. So that's I would say, probably expected phenomena. Hydrogen is an amazing material to use for generation of energy, but you need to know what you're doing. And if you don't know what you're doing, it can end up really bad. We know what we're doing. So we built our knowledge base and the capabilities, procedures, et cetera, for 2.5 years with renowned experts across the United States and globally that actually came and actually worked with us to develop all those platforms. It's complex. It's not simple. And you need to maintain safety. That's the key for what you're doing when you're dealing with hydrogen. And you have to do, like I said, you have to know what you're doing. You can't just say, okay, I'm going to put a fuel cell with hydrogen, it's going to work. It's not.
Thank you. So you guys all don't know this, but he does. We run, one of the things we do is we invest in data centers. So from a cost standpoint, I know we talked about time and reliability. Yeah. From a cost standpoint, can you tell me what the numbers look like, both on the CapEx side as the OpEx side?
Yeah, so let's start from the OpEx side. That's another aspect of concern that was with our customers is if you run on hydrogen, it's going to be very expensive to operate. And the answer is no, it's not. We generate energy at 6 cents per kilowatt hour. So we can actually compete with a lot of the data center fed by grid today. And we have what's called escalator, because the more hydrogen we use, the lower price we pay for the hydrogen, which means that we can actually give to our customers a drop in price of energy over the time, which no other data center will offer you. So from an operational perspective, we are also very dense. Since our baseline rack is 75 kW, then we put on a megawatt on 1,000 square feet, which means that we do not need a lot of techs on site to be able to operate it. And we have an AI self-managing DCIM. So the site is being managed by an AI agent that has been trained on our site in Mountain View. So we reduce our operational costs dramatically, and we transfer it to the customer. I can tell you that with large customers, hyperscalers, we can drop their TCO by 30 to 40% from the traditional co-location engagement. And from a CapEx perspective, we're right now at about 30 to 40% below cost of traditional data centers. Now, it sounds too good to be true, and that's the reason why we built one, just to prove that it's actually true. And so we have the receipts to show that we are at that level of cost. We are very attractive in cost to build. We're very attractive in cost to operate. And because our turnaround is very quick, we actually can operate at a very fast pace and not requiring a lot of resources for construction.
Can you talk to us about a little bit about a large project that you're working on?
Yeah. So we announced last year a 1 gigawatt site that we're building in Texas. It's a site that connects directly into a hydrogen distribution system, which is sitting next to Houston. That's a site that will be able to actually accommodate 1 gig with an option to do an expansion to another gig. We have the hydrogen secured, and that's the key aspect of it. So it's like saying, I have a piece of land which has 2 gigawatts of power connected from the grid. We have a piece of land which has 2 gigawatts capacity of hydrogen. So we can build it out. Initially, we're probably going to do a larger spousal. So we do 25, 50, 100, and 150 pieces for customers who wants that size. In the future, we might do smaller. Or if we go for a hyperscaler engagement, we're probably going to actually build a large 500 or a full gig for a hyperscaler. It's a combination of the two. And those are the first two engagement, the gig that we announced and an option to expand to another gig. In the next 5 years, we would like to build between 4 and 5 gig of the technology that we have. We believe that we have something which is differentiating in a data center, not just because we can build without dependency on the grid, but also because we are fully sustainable. And there isn't a solution right now in the market which is fully sustainable with zero emission. Even though some of our hydrogen is not green, we do have a mix of hydrogen sources. But beyond the fence, inside the data center, we're zero emission and we don't use any water, which is very unusual and very rare and highly, highly accepted by the communities we come into, because we bring to them economical development by our investment, but we don't load the resources, the local resources, and they basically appreciate it very much and help us in any way they can to be successful with them.
Well, it looks like we're out of time.
Yeah.
But, it was really nice to talk to you.
Thank you very much.
And I really enjoyed this conversation.
Great. Thank you very much.
Thank you.